Well, if you're watching this video, then you weren't entirely put off by the grueling day one, and you've come back for more for day two. Welcome back. So this is going to be an interesting day. It's going to be different to day one. It's going to be shorter than day one. You'll be happy to hear. But also it's going to be pure theory. We're going to be talking about agents and agent architecture. Almost all of the days on this entire 6 weeks program are very practical heavy. This is one of the rare days that is going to be a theory day, but it's going to be interesting. It's going to be really great. I'm going to tell you all about agentic architecture. Let's get to it. So where better place to start than with the almost obligatory, what is an agent kind of question? And the interesting thing is that there's not actually a great answer to that. Agentic AI is one of these things that's been super hyped and generated a lot of excitement, and people are using the term to mean a lot of different things. And in fact, there was a meme going around last year about how agentic AI could mean almost anything. But having said that, typically there is one simple definition. And actually the definition that I'm pulling has come from Hugging Face, their small agents project, where they give a really nice, crisp, simple definition. And they say AI agents are programs where LLM outputs control the workflow. So basically, one output from LLM is able to decide what tasks are carried out in what sequence. So that is a good, crisp definition. It's something for you to keep in mind, and it applies in some situations and not in others. More generally, though, you will find that there are different hallmarks of what makes something an AI solution. And people will often use the term agentic AI or agents if any one of these 5 hallmarks are met. So first of all, sometimes any solution that involves multiple LLM calls could be called agentic AI. And, a bit like the one that we just built in day one, that could be called agentic AI. Now, this one, LLMs with the ability to use tools, that's often what people think of as the kind of litmus test for whether something is agentic. If you remember when we looked at the N8N idea at the beginning of the first lecture, when I had it turn on the lights that I was wearing, that was an example of tool use. And we're going to be talking a lot more about tool use. So that's obviously a hallmark quality as well. Another is when you have an environment set up which allows different LLMs to send information to each other, a kind of coordination, orchestration environment. That in itself, for some people, defines agentic AI. Sometimes it's when you have a planner, some process that's able to coordinate activities, and that itself is an LLM. That is, and that's quite similar to the text in blue, that for some people is the hallmark of agentic AI. But for some people, for a lot of people, there's this word autonomy, and that really captures the essence of agentic AI. And this word is saying that we are giving some ability to an LLM to control what order things happen in or what happens, to sort of choose its own adventure in some way. And giving it that autonomy, giving it, if you will, that agency, is one of the ways to define agentic AI. And in some ways that sounds kind of spooky, like what does it mean to have an LLM, a statistical language model that is autonomous? And to be honest, it's just sort of fancy use of language. In many ways, you could argue that exactly the project that we just did, the challenge that I set you to have an LLM come up with a business sector that would then be analyzed for pain points. In some ways, it was showing autonomy there because it was able to choose what business sector to use. And even more straightforward was when we asked for a question and then we had it answer the question. It had a level of autonomy. So you can see how any time when we're giving an LLM the opportunity to decide how we will carry out future actions, you could think of that as giving it autonomy, and that being a way to describe agentic AI. And just to go one level deeper, Anthropic wrote this brilliant post that's called Building Effective Agents. And I will refer back to that many times because I think it's just so clear and well written. And in that particular paper or that blog post, they distinguish 2 types of what they call agentic system. So this is their terminology, but they would say that there's this umbrella term, agentic system. And under that umbrella term, there are 2 different categories. And one category is called workflows. And these, as it says, are systems where models and tools are orchestrated through predefined paths. And they delineate between that and something called agents. And agents are where models dynamically direct their own processes and tools, maintaining the control over how tasks get accomplished. So these are the two different sort of subfields under agentic system. There are workflows and there are agents. And you can see they're sort of hinting that perhaps the things that a lot of people call agents are in fact workflows. So they're drawing that distinction, but they do still describe the whole thing as being agentic systems. So it's a bit of wordplay there. Does that mean that workflows are agentic or not? I guess they are, but you can see there's some ambiguity in the terminology, but I do think this is a helpful framework for distinguishing between these two worlds. And we're now going to go deeper. We're going to look at each of these and look at some common design patterns. And this should hopefully start to bring things to life and show you about how we can apply this kind of thinking to actual projects. Next, we're going to peel back the onion a little bit more on workflows, looking at different types of workflow. Anthropic identifies 5 different design patterns that you'll find when building agentic systems that have workflows in them. And let's go through each of them and talk about them. This is the first one. They call it prompt chaining, and it's a simple one. What you're seeing here in this diagram, obviously the in and the out on the left and the right is the beginning and the end of the workflow. The yellow boxes represent calls to models, to LLMs, and the blue boxes is where you potentially have just some code that you've written, some software, and it's optional. And what you'll see there is that this is simply saying you could have an LLM carry out some task, and then potentially, based on some code, you could then pass that to a second LLM, and that output could go to a third LLM, and that could be the conclusion. And actually, this is really similar to what you just did. This is similar to that commercial question when we ask an LLM first, pick a sector, and then given that sector, pick a pain point, and then pick a solution. And obviously it doesn't need to be 3 LLMs, it can be as many as you want. But this is the idea: you are chaining a series of LLM calls, decomposing into a fixed set of subtasks. And the reason you might want to do that is because you can take care to frame each LLM call very precisely to get the best, the most effective LLM response based on that prompt. So it allows you to really work on each of those tasks being very effective, and then keep your whole process, your workflow on guardrails by taking it step by step through a sequence of well-defined tasks. Now, I want to make a point that you might have already thought of. Whilst Anthropic is quite clear to define this as a workflow and not an agent pattern, it is perfectly possible for prompt chaining workflow like this to be giving the LLM some discretion on what activities happen. Because just as we did in our example, the first call to the LLM might come up with a topic, and it's that topic that gets worked on by LLMs 2 and 3. So in some ways, the way that Anthropic distinguishes between workflows and agents, it's a little bit artificial. There is definitely a blurred line between them. It's perfectly possible for there to be an element of autonomy about a workflow pattern like this. Onwards, the second design pattern is called routing, and this is where an input comes in and an LLM has the task of deciding which of multiple possible models are selected to carry out this function. And the idea is that you might have specialist models. In here, they're shown by LLM 1, 2, and 3, and they're each good at different tasks. And the router's job is to classify the task, understand which of the specialists will be best equipped to tackle this task. And it allows for, as I say here, separation of concerns, for being able to have different LLMs that have different levels of expertise and have an LLM decide how to route to those experts. So this is a powerful model. It's very common, and it's something which, again, I would argue it's a bit artificial to say that there's no autonomy here, because clearly that router is able to make some decisions, albeit on guardrails. Again, it still has to follow a given workflow. And on to the third design pattern, parallelization, which is, at first blush might look quite similar to what we just talked about. There is a lot in common with these design patterns. But the idea here is that you have, remember the blue boxes represent code, our code, not an LLM. So we write some code that takes a task and breaks it down into multiple pieces that should all run in parallel. So in the previous design pattern, it was an LLM doing the routing, and it was one of these three experts that was given the task. In this design pattern, it's code, it's, let's say, Python code that's deciding what to do, how to coordinate, and in parallel, it's being sent to three LLMs to carry out three different activities concurrently. And then there's more code, maybe it's Python code, that takes those answers and stitches them together. And actually, Anthropic makes the point that these tasks don't necessarily need to be different tasks. You could imagine a situation where you send the same task and have it be done 3 times, and you use the aggregator perhaps to take the average or something like that. So there are various situations where this might be the same thing that you're doing 3 times. It doesn't need to be different. But I think most commonly, it's when there are multiple subtasks happening concurrently. That is the parallelization, it's a hard word to say, of the design patterns. Okay, and now this one, orchestrator worker. This is when a difficult, challenging task is broken down and recombined. And you might be thinking, hang on, isn't that just what we just did? I just flicked between them. Don't these two slides, these two design patterns look really similar? Well, you'll notice a subtle color change along with a change in terminology. The key point is that this is exactly like the prior design pattern, except it's no longer code that's doing the orchestration. It's an LLM. So you are using a model to break down a complex task into smaller steps. And then you are using a model to combine the results. And so this is a much more dynamic kind of system where the orchestrator can choose how to divvy up the task. And again, I would argue that it's quite artificial to categorize this as a workflow rather than an agent pattern that we'll look at in a minute, because clearly that orchestrator has discretion over how it divvies up the tasks, and it could choose how many different LLMs get assigned the activity. So saying that this is just a fixed workflow is perhaps a stretch. So, I think you get the overall idea. There's certainly more constraints on this than when we come to the more flexible agent flows. But generally, the idea here, LLM breaks down the task, LLMs carry out each expert task, LLM synthesizes the task for an output. That is pattern 4, the orchestrator worker. And now onto pattern 5, the final workflow pattern, and the one that I use most commonly. This is one that I come against all the time. And it's called an evaluator optimizer by Anthropic. I tend to call them just evaluators or validation agents. You hear that a lot. But the idea is, it's very simple. You have an LLM that's doing your job. Let's call it the LLM generator. It's doing something and it comes up with a solution shown in this white arrow here. And you have a second LLM that's playing the role of evaluator. It's there to check the work of the first LLM, and it's given any extra information, any context, everything to arm itself to not be trying to generate content, but check the work of a prior LLM. And based on that, it can choose to either accept or reject the work. If it accepts it, then that's it, goes to the output. If it rejects it, it should come up with a reason, and the rejection and the reason goes back to the LLM generator, and that can then choose to come up with another solution, which comes back here. And so you can see this sort of feedback loop setup. It's very powerful. Of course, one of the key concerns of building production systems with LLMs is about accuracy, predictability, robustness of the responses. And having validation agents, having these kinds of evaluator optimizer flows in your LLM solutions is a really powerful way to increase the accuracy and build more guarantees. There's never full guarantees with LLMs, but build a higher level of guarantee around the quality of the final output. So this is a really effective pattern. I use it all the time. And of course, we'll have plenty of examples on the course, and you should be able to think about how you could apply this to LLM solutions in your day jobs right away. And so with this, we now turn to the other category, the second category of agents. So by contrast with the workflow patterns, with agents, the process is more open-ended. It's something that can keep going. It has feedback loops. It's typically a design that allows for information to come back and be processed multiple times. And importantly, there's no fixed path through the design pattern. It's not like there's a series of steps as we had in those prior patterns, but rather it's something that's fluid and dynamic. And as a result, it's something which can be much more powerful. There's a much greater kind of problem that could be taken on by this sort of agent pattern, but it's less predictable. And so there are absolutely concerns about robustness, about guardrails, about how do you get the best out of this kind of flexibility, but still have a system that can run in production and be guaranteed to complete in a certain time, and so on. And this is the diagram that I would bring up, which is a fairly generic kind of diagram that's just meant to show that you have the inputs and outputs now shown as a human, but we don't really have output anymore. We have environment that's meant to reflect some sort of outside world that can be interacted with, such as the lights that I wore around me. That the human can make a request that goes to an LLM. The LLM is able to take actions on the environment, as you can see, and the LLM is able to get back information from the environment in some way. And then this is simply a repeating loop. The LLM can continually make other actions and get back feedback. And at such time as it desires, it can choose to stop. And so this is the diagram, and there aren't more specific design patterns because it is in itself this sort of open-ended design pattern. It's saying this is it's almost a sort of meta design. It's saying the LLM gets to choose its own design for how it's going to solve the problem. And that's really, it's quite hand wavy, but that's the way to distinguish it. If we look back at this pattern, I mean, this pattern arguably also could keep going forever. It's not as if this has a fixed stop, but there's clearly more certainty about what's happening for what reason than with the agentic patterns, where it is more fluid by its nature. So that's really the core idea behind the agent patterns, that there is much more flexibility that allows us to be able to solve much more complex problems where LLMs can really plot their own paths. But it does introduce some new issues, such as not knowing how long it will take before it will complete its task, not knowing whether it will complete its task at all, not knowing what kind of quality outputs we will get, and not knowing how much it will cost. These are all the kinds of challenges that agent developers like ourselves need to face. And they are the sorts of things that we will be tackling in the coming weeks. And so if this feels a bit unsatisfying, that the design patterns for workflows are so clear and now this looks just so loose, then all I can say is, as we put this into practice, as we code different real agent environments, this is going to become more and more concrete, and you're going to be able to, you'll see this as second nature before too long. Now, let's just quickly say a few more words about some of the drawbacks that I alluded to a second ago with using agent frameworks and agentic AI and design patterns. So obviously, there is this sense that you have an unpredictable path. You don't actually know what order tasks will take place in, or even what tasks will happen. You don't know what the output will be. There's no guarantees that you're going to get a great output. Now, this whole agentic architecture allows us to take on much bigger, harder problems than we've ever been able to take on before. But it does have this inherent uncertainty associated with giving LLMs autonomy over how they tackle problems. There's also unpredictable costs. I alluded to that as well a moment ago. But because you don't know how long it's going to take, you don't know how much it's going to cost in terms of running the APIs and potentially building up a big bill. And so, as a result, there's a couple of mitigations that are incredibly important, both of which we will spend plenty of time on in the coming weeks. One of them is, of course, monitoring, being sure that you have the kinds of visibility into what's going on behind the scenes, so you can understand what's going on with your models, with their interactions, particularly when you have potentially many agents all interacting. And we're going to see that with OpenAI SDK. We're going to see the trace, the ability to watch different agents interacting. When we look at LangGraph, we're going to see LangSmith, their tooling. So we're going to see a lot of the ways that you can have this visibility into what is going on under the hood in your agent systems. And then guardrails. Guardrails is the name for the kinds of protections that you can write in software that makes sure that your models are doing what they should be doing, or that they're not sort of leaving some constraints, some rails that you put in place. And in fact, that quote that I put here comes straight from the OpenAI Agents SDK, which has a ton of functionality dedicated to guardrails, and they say that it ensures they behave safely, consistently, and within the boundaries that you wish. And so we will be building those guardrails ourselves in week 2. And with that, that does actually conclude the day 2 lectures. As I promised you, it was shorter than day 1, and I hope you didn't mind that we covered a lot of theory. It's really interesting stuff, these agentic design patterns. I hope now you've got some clarity on what agents are, and that there is ambiguity on this, but ways that you can talk about it and think about what it means to be autonomous and what it means to be able to plot your own path. Let an LLM decide the path that things will take. And so with that, congratulations on completing day 2. In day 3, we're going to talk about orchestrating LLMs. It's going to be more coding, more hands-on, which will be fun. We're going to build with a lot of APIs and get ready for that. And after that, we're going to move on to tools. So I will see you next time.